All right, everyone. Let's start. Paper 5 Planning, Analysis, and Evaluation of A level, May June 2025, Variance 51. We have done Variance 52 in the last class. Now we are doing Variance 51. Let's see what we have in this paper. Oh, my goodness. Okay. Now, question 1 is belongs to Grignard reagent. Well, Grignard reagent is not the part of AS level in A2 level course, but examiner is asking the question on that, which means you should know. Grignard reagent is also called organometallic compounds. It is also called alkyl magnesium halide, and it has a general formula of that. Okay, where R is a hydrocarbon group and X is a halogen. Could be any halogen. It could be alkyl magnesium chloride, alkyl magnesium bromide, or alkyl magnesium iodide. Grignard reagent is basically benzyl magnesium bromide is used as an intermediate in the reaction between bromobenzene and ethanol, which is an aldehyde, to prepare 1-phenyl ethanol. An organic solvent ethoxyethane is used. By the way, Grignard reagent is extremely reactive species. Okay. And bromobenzene is basically an aromatic alkyl halide, also called aryl halide. And all aromatic compounds are highly volatile. Okay. Ethanol is basically an aldehyde. And ethoxyethane is used as an organic solvent, but remember, ethoxyethane contains some amount of water. All right. So to remove water from ethoxyethane, this solvent must be dry. So to remove water, distillation technique can be used. Distillation, or you can say fractional distillation. It doesn't make any difference, okay? Why water is very much important to remove from this ethoxyethane? Because alkyl magnesium halide, I mean Grignard reagent, is very, very reactive. It can easily hydrolyze with water. So to prevent the hydrolysis of this Grignard reagent, we need to remove water via distillation. Okay. This reaction takes place via 3 steps, and that is the product of the reaction. Okay. The preparation involves the following step. Okay. Set up the apparatus as shown in figure 1.1, and that's your figure 1.1. We need to set up the experiment like this. With approximately 1.25 gram of magnesium powder. So powder is used to increase the surface area. And so the rate of reaction increases, all right. And 5 cm cube of ethoxyethane in the round bottom flask. So in this round bottom flask, we have magnesium plus ethoxyethane. All right. Now, the most important thing is 0.05 moles of alkyl benzene, which is bromobenzene. That's very, very important value of bromobenzene. Okay, we need to remember this value. To the round bottom flask, dropwise. Why dropwise? To prevent violent exothermic reaction. Okay, using a tap funnel and leave until reaction 1 is complete. Okay, so this tap funnel contain okay, so this tap funnel contains C6H5Br, and you need to add drop by drop bromobenzene into this funnel. And when this compound is reacted with these reagents, obviously alkyl magnesium bromide is formed, and that's going to be your Grignard reagent. Okay. Dissolve 3.0 cm cube of ethanol into 50 cm cube of ethoxyethane and add this solution to the round bottom flask using tap funnel. Leave until reaction 2 is complete. So we need to add 3 cm cube of ethanol. So this round bottom flask also contain ethanol. Okay. Remove the condenser, tube Y, and tap funnel from the round bottom flask. Add 40 cm cube. What does it means? It means reaction is finished because we are removing the apparatus. Okay, that's the meaning of this whole statement. Add dilute, add 40 cm cube of dilute hydrochloric acid to the round bottom flask so that the reaction 3 takes place. Uh, why are we adding HCl and why 40 cm cube? 40 cm cube of HCl means it has to be in excess. Second thing, um, this HCl is used to donate hydrogen ions. And these hydrogen ions can also react with magnesium. And when magnesium is treated with hydrogen ion, you will get bubbles of gas. Is given off or released. Transfer the content of the round bottom flask to the separating funnel. Allow the liquids to settle so that 2 layers are formed. Uh, by the way, these 2 layers, one could be organic, the other one could be aqueous. Okay. Could be organic layer and could be aqueous layer. Open the tap of the separating funnel and run the lower layer into the beaker labeled A. By the way, the lower layer is found into this beaker A. and this lower layer means lower density. This lower layer means higher density. Hold on. And if it has a higher density, meaning it could be inorganic salt plus acid. Okay. On the other hand, upper layer labeled beaker B. So this labeled B beaker contain upper layer, and upper layer is basically lighter, lighter, and that means it belongs to ethoxyethane and alcohol. Oh, ethoxyethane, my bad, not alcohol, ethanol plus ethanol. Okay. So water has higher density than ethoxyethane, which is why beaker A contain water with this whole thing. That is going to be the lower layer. Okay. This is going to be the condenser, and condenser has two outlet, this one and that one. This one indicate water inlet, this one indicate water outlet. Let me label that. This is water out, and this is water inlet. Okay. This is tube Y. All right. This tube Y contains solid Z, and then this solid Z is basically drying agent, and drying agent could be anhydrous calcium chloride. Okay. And why uh, there is no rubber bung here? That's a lot of information, guys. Let me change the color. Why there is no rubber bung here? To prevent pressure building up in the apparatus. And also, this open tube is used to maintain the airflow. All right. I mean to say, allow air to enter or exit into the system. Okay. This tube Y is also called drying tube or guard tube. Anyway, let's move on to the next part of the question. That's the explanation. I hope it makes sense to you. I hope you get the point. Some relevant data are shown. Uh, we have densities, we have boiling points, and we have hazards. Okay. So use the information in table 1.1 to suggest why the following safety precautions are used. Wearing chemically resistant gloves because bromobenzene is skin irritant, which is why we need to wear chemical resistant gloves, also called nitrile gloves. Using a fume hood or fume cupboard is used if the gases are toxic. So bromobenzene is toxic, ethoxyethane is toxic, and 1-phenyl ethanol is toxic. All right. Also, ethanol is has a respiratory irritant, eye irritant, which means we need fume cupboard or fume hood, right? So what we can write here, that, and these are the gases because they have a very low boiling point, right? These are the gases. All right, these are the gases. So these gases, these substances have low boiling point, which means they exist in gaseous state at RTP. So can we write here that some gases are toxic? Okay, like ethoxyethane and ethanol. Dry apparatus and reagents are essential for step 1 to 3. Suggest how the glassware shown in figure 1.1 should be dried before use in step 1. So the entire glassware, we need to dry the entire glassware by using an oven. So we can say कि use oven to dry the glassware. And why we need to, dry the apparatus and the reagent? Because Grignard reagent is extremely reactive. It undergoes nucleophilic addition reaction. So to prevent that nucleophilic addition reaction, I need to, go for these two steps. Look, the ethoxyethane contain a small amount of water. Suggest how the water can be removed from ethoxyethane before use in step 1 and 3. So that's what I have told you. So ethoxyethane contain water. We need to go for distillation or fractional distillation. So I'm going to go for distillation. Distillation can be used. Figure 1.1 shows the apparatus for step 1 to 3. Draw a labeled arrow on figure 1.1 to show where the water enters the condenser. So that's what I have done here. That's the point where water into the condenser, and that's the point where water comes out from the condenser. Okay. Suggest why solid Z is used. Solid Z, I believe, was a drying agent. So drying agent could be calcium anhydrous calcium chloride. Solid Z is used as drying agent. Could be anhydrous calcium chloride. Give one reason why the apparatus does not have a bung at the end of the tube. That's what I've told you. It doesn't have any bung here. So gases can be removed from here, but that's not going to happen because we need to maintain the pressure, okay? To prevent the pressure building up in the apparatus, or we can say to maintain the airflow, or to maintain the airflow in the apparatus. So you can write either one of them, okay? Let's move on to the next part of the question. In step 1, approximately 1.25 gram of magnesium powder is needed. Okay. Outline how the student should accurately weigh by difference using a weighing board so that the exact mass of magnesium transferred into the flask is known. Okay. So first of all, weigh an empty weighing board. Then weigh the weighing board plus magnesium before transfer. Okay. The next is reweigh the weighing board plus magnesium after the transfer. And last but not the least, mass of magnesium transfer. Oh, now in the next part of the question, examiner is saying include the results table with appropriate headings ready for the student to fill in. Okay. So what we can write here, mass of weighing board in gram. Okay. Mass of both, I mean weighing board plus magnesium before transfer in gram, obviously. Oh, my bad. Hold on. In mass, that's gram. I'm going to write the value here. Okay. Then mass of both plus magnesium after transfer. And last but not the least, mass of magnesium transfer. Okay. Use the information. That's a very tricky question. Use the information in table 1.1. Okay. Information in table 1.1. So table 1.1 gives you density of different substances along with the boiling points. So I'm going to get density from here. I'm going to use density from this table. And then determine the volume in cm cube of bromobenzene used in step 2. MR of bromobenzene is given. Yeah. Density is basically mass per unit volume. So first of all, let me find out the mass of bromobenzene. So my first is mass of bromobenzene. So we need moles into MR. Moles already given in the question, which was 0.0500 moles. These are the moles, okay? 0.0500 moles. 0.0500 moles into MR is given, which is 156.9. So what's the value actually? 0.0500 into 156.9. 7.845 gram. Okay. I've got the mass. I know the density equals to mass per unit volume. We need to find the volume. So mass is 7.845 and the density of bromobenzene from table 1.1 is 1.50 divided by 1.50. So it's going to be 5.23 cm cube. The bromobenzene is added dropwise in step 2. Suggest one reason why bromobenzene is not at all the ones. So dropwise to prevent violent exothermic reaction. To prevent violent exothermic reaction or to prevent overheating. And I think ये हमने discuss किया था यहाँ. That's the thing. Why dropwise? Okay. Suggest why measuring cylinder is suitable piece of apparatus to measure 40 cm cube of hydrochloric acid in step 5. So hydrochloric acid, volume of hydrochloric acid uh, is not accurate. Examiner has written 40 cm cube. If it was an accurate value, it has to be 40.0 cm. Since examiner has written only 40 cm cube, which means it's not an accurate volume. So we can use measuring cylinder. So volume is not precise technically. Not accurate term is not good. Not precise. So we can use measuring cylinder. And why the volume is not precise or accurate? Because HCl was in excess. Okay. That's the statement. Okay, let's move on to the next page. Oh, the separating funnel used in step 6 and 7 as shown in figure 1.2, the final product 1-phenylethanol in the ethoxyethane layer. So 1-phenylethanol and ethoxyethane State whether beaker A or beaker B contain the layer with 1 phenyl ethanol after step 7. Let's go back to the information. um, क्या कह रहे हैं? I think examiner is looking which beaker A and B contain organic layer and 1 phenyl ethanol. So I think beaker B contain this layer. I'm going to write beaker B. Why? Because ethoxyethane is lighter than water. See, the density of water is greater than ethoxyethane, which means ethoxyethane is lighter than water. Okay? Which is why ethoxyethane um, has to be in the lower layer, which contain 1 phenyl ethanol with ethanol. Okay? Oh, that's a very lengthy question. Oh my goodness. Next part of the question is the overall reaction can be represented as shown. This is bromobenzene. This is ethanol. This is magnesium. This is HCl. I mean, H ions comes from HCl. So this becomes your product, and this is basically magnesium bromide. At the end of step 8, 2.17 gram of 1 phenyl ethanol is obtained, and that is going to be your practical yield. Okay. Determine whether bromobenzene or ethanol is the limiting reagent, and hence calculate the percentage yield of 1 phenyl ethanol. Show you working. MR of 1 phenyl ethanol is given. Oh my goodness. That's a lot of. Okay. Let's talk about ethanol first. By the way, density is always equals to mass per unit volume. Okay. So ethanol has 3 cm cube volume. This one. So volume is given, density is here. I can find the mass. So mass of ethanol is density into volume. Density is basically 0.788 and volume is 3.0 cm cube. So the mass of ethanol is going to be 2.364 gram. Okay. So moles of ethanol, moles of ethanol. My bad, I'm getting moles of ethanol. It's 2.364 gram divided by the MR of ethanol, which is 44, which you need to determine on its own by using the periodic table. So when we talk about 2.364 divided by 44, it's going to be 0.0537. 537 moles, okay? Oh my goodness. Third step, these are the moles of ethanol now. I've got the moles of ethanol. So I need to find out whether the which one is the limiting reagent. We need to determine the moles of both bromobenzene and ethanol. So I've got the moles of ethanol. Now I need to find the moles of bromobenzene. So moles of bromobenzene is already given in the question. And that was 0.0500 moles of bromobenzene, right? Okay. So moles of bromobenzene already given 0.0500 moles. Now, which one is the limiting reactant? Obviously, bromobenzene is the limiting reactant. And obviously, ethanol has to be in excess. Okay. To determine the percentage yield, I need to find out the theoretical yield of 1-phenylethanol. And for that, I need the mass of bromobenzene. So again, to get the mass of bromobenzene, moles needs to multiply with the MR, and MR was how much? 156.9, and that's basically how much? 7.485 gram. And I believe that's the value we have calculated in the last part also, isn't it? That's the value. So it doesn't make any difference, because examiner is looking for the working, so we need to mention that. So that's the theoretical yield, guys, for one bromo. Uh, MR of that, MR of that. Yes, that's the theoretical yield. Okay. Now in the next step, step number 5, C6H5Br and this 1-phenyl ethanol has 1:1 ratio according to the equation. The MR of bromobenzene is 156.9. The MR of 1-phenyl ethanol is 122.0. That's given in the question. When we have got 7.485 gram, so mass of 1-phenyl ethanol. Yeah, that's the, hold on. Mass of 1-phenyl ethanol is going to be 6.1 gram. And guys, that's your um, theoretical yield of 1-phenyl ethanol. Practical yield is already given. So using these two values, I can find the percentage yield, and that's going to be my next step. Um, that's not the percentage, that's not the theoretical yield of 1-phenyl ethanol. So percentage yield is 2.17 divided by 6.1 into 100. Let me check. 2.17 divided by 6.1 into 100 is going to be 35.57%. Okay. So it's going to be 35.6%. All right. That's the last point. Last question. Suggest why the infrared spectrum of the product detected the presence of carbonyl group peak. Carbonyl group peak appears due to the presence of ethanol because ethanol is found in excess. So ethanol is in excess, which contain carbonyl group, So shows peak in the IR spectrum. Okay, and that peak normally appears at 1700 centimeter inverse to 1720 centimeter inverse. That's what we have discussed in the class. That's the end of first question. That's a long question. That's a lengthy question, and it's tough because it has a lot of calculation, and calculation भी easy नहीं है. Calculations are a little bit tricky. Okay. Anyway, that's the first question. My goodness. Let's move on to the next one. What we have in the next question, oh my goodness, again calculation based question. All right, an experiment is carried out to determine the rate constant K for the hydrolysis of ethyl ethanoate using a hydrochloric acid as a catalyst. The equation for the reaction is shown. The rate equation for this reaction is shown. So with respect to ester, it is first order. So rate equation shows order with respect to ester is first. Okay. And that indicates H plus sign acting as a catalyst. It will take part in the reaction, but at the end, it will recover as it is. So I believe with respect to this, it's going to be zero order reaction. वैसे ही एग्जामिनर चेंज भी कर देते sometimes, ठीक है? So इस क्वेश्चन के लिहाज से it is zero order because it is not given in the rate equation, which means it is zero order. The progress of the reaction is followed by determining how the concentration of acid changes with time. So concentration versus time graph. Must be expected. A portion of the reaction mixture is removed every 5 minutes and titrated with sodium hydroxide, NaOH. Final titration is carried out after 180 minutes. Okay. A student carries out the following steps: 70 cm cube of iced water to 7 separate small conical flasks. Now the main question is, why iced water? Iced water is used to quench the temperature or to control the temperature. Quenching के लिए भी यूज होता है ये sometimes. And also when it makes the dilute solution also, or it dilutes this to dilute the solution. To dilute the solution. Okay. Add few drops of naphthalene indicator to each flask. Naphthalene is pink in alkaline condition and colorless in acidic condition. Okay. Using a measuring cylinder to transfer 100 cm cube of 0.2 mole per dm cube HCl into a large conical flask. So 5 cm cube of ethyl ethanoate to a large conical flask and swill the flask to mix the content. Start the stopwatch. Okay. Start the stopwatch. All right. But that's a very important statement. We need to swill the flask to mix the content, okay? To get the better results. Transfer 10 cm cube of reaction mixture to one of the small conical flasks containing the ice water and indicator. Record the time. Shake the small flask. By the way, this recording the time could be the source of error. हो सकता है मैं टाइम सही तरह से रिकॉर्ड ना कर सकूं. मैंने पहले रीडिंग ले ली थोड़ी देर के बाद रीडिंग लेनी चाहिए थी मुझे, सही है। तो दैट्स पॉसिबल। Could be the possible source of error। स्टॉप वॉच देर से स्टार्ट की है, स्टॉप वॉच अर्ली स्टार्ट कर ली, स्टॉप वॉच जल्दी बंद कर दी या देर से बंद कर दी। कुड बी एनी पॉसिबल सिनेरियो ऑफ एरर। सोर्स ऑफ एरर। ओके। Carry out the single titration of the mixture in the small conical flask using 0.1 mole per dm cube NaOH, which means conical flask has HCl. Conical flask has HCl, right? And burette has NaOH, right? So technically, color observation at the end point would be colorless to pink. Part A, give two reasons that explains why the use of ice water in step 4 decreases the rate of reaction. Decreases the rate of reaction. So technically, mm, to control the temperature. So technically, rate of reaction decreases, which means it quenches the temperature, it lowers the temperature. So it lowers the temperature is the best word, I believe. That's tricky. Since examiner is saying decreases the rate of reaction, which means ice, water, or ice lowers the temperature. When it lowers the temperature, lowers the kinetic energy, lowers the rate of reaction, okay? Because it lowers the collision frequency also. And second thing, I'm not sure about the second thing. What's the purpose of the second thing? Uh, when the solution becomes too diluted, obviously the number of reacting particles decreases, collision frequency decreases, and rate of reaction decreases. So to make the solution dilute, uh, that was right. To make the dilute solution, so as you dilute the solution, number of reacting particles decreases, collision frequency decreases, and so rate of reaction decreases. So rate of reaction decreases is the most important term. Describe one observation that is used to determine the endpoint of the titration. The endpoint of the titration should be colorless to pink. Conical flask has HCl, which shows colorless solution with phenolphthalein. When you titrate it with NaOH, it turns into pink. So in alkali, it shows pink, which is why the endpoint of the titration is colorless to pink. Okay. Next, oh my goodness, the result of the experiment are shown in table 2.1. Vt is the titer at a given time t. V infinity is the final titer at t 180 minutes when the reaction is assumed to be complete. Okay. So when at 180 minutes, the Vt titer given time is 45.70, and at that point the reaction has finished. Okay. Okay. Complete the table 2.1. Give your answer in column 3 to 2 decimal places and your answer in column 4 to 4 significant figures. So examiner is looking for the answer to 2 decimal places, 2 dp and 4 sig fig. Okay. And that's tricky, guys. When you subtract these two values, you will get the value here So the value is going to be 33.7. So two decimal place, it has to be 33.70. It has to be 29.30, 23.55, then 22.25, then 19.40, and then 17. So it should be 17.00. Now use the log value, apply log values on the, apply log on these values, you will get the value in this column. And examiner is looking for the fourth sig fig. So it's basically, hold on, log 33.70, 1.5276. So it has to be 1.52876, राउंड ऑफ होकर 1.528, 4 sig fig हो गया. Then 29.3, 1.467, then 1.372, 1.347, 1.288, and then 1.230. Okay. Oh God, I hope it makes sense to you. Next part of the question is plot a graph on the grid, show the relationship, use cross X to plot each data point, draw a straight line of best fit. Okay. All right. Okay. Let me copy this table to plot the graph on the next page. That's tricky. Oh my goodness. It's very, very tough for me to write or to read such a small boxes on the graph. So to get the better result, I think I need to work on it. It's 1 point. Let me read. Okay. This is 1.1, 0. This is 1.11. This is 1.12. This is 1.13. This is 1.14. And then 1.15. It's going to be 1.16, 1.17, 1.18, and 1.19, and then 1.20. Okay. Then 1.21, 1.22, 1.23, 1.24, and then 1.25, 1.26, 1.27, 1.28, 1.29, and then 1.30. Because of my eyesight, I cannot read the small boxes accurately and precisely, which is why I have to work like this so that I can make an accurate graph for you. So that requires a lot of effort. My goodness. 1.31. Okay. 1.31. 1.32. 1.33. 1.34. 1.35. 1.36. 1.37. My goodness. And then 1.38, and then 1.39, and then 1.40. 1.41, 1.42, 1.43. They are okay. 1.43, 1.44, and then 1.45. My goodness, this is 1.46, 1.47, 1.48, 1.49, and 1.0, 1.51, 1.52, 1.53. Oh my goodness, 1.53 and 1.54, and then 1.55. Okay. Oh, now on the x-axis, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then 25. 25, 26, 27, 28, 29, and then 30. Okay. Oh my goodness. Let me draw the table. Okay. So first at 0 we have 1.528. 0, 1.528. 1.528. 1.528. Somewhere around here. Okay. Then at 5, 1.467. 5, 1.467. 1.46 and 7. 1.45, 1.46, 467, 467, somewhere around here. 46, this one. Okay. Then at 15, 1 point, oh, but 10, at 10, 1.372. At 10, 1.372. 372 here. Okay. At 15, 1.347. 15, 1.347. Here. Okay. Somewhere here. All right. Then at 20, 1.288. 1.288 at 20. 1.288 to 1.288. Somewhere here. And at 25, 1.230. 1.230 here. Okay. So examiner is looking for the straight line. That's what he has instructed us. So we need a straight line, best fit of a straight line. Okay. So let me draw the best fit of a straight line. Okay. Next part, circle one point on the graph that you consider to be the most anomalous. Most anomalous is going to the one which is further away from the line of best fit, and that's going to be this one. Okay. The anomalous point at 10 minutes is going to be the anomalous point. Suggest one reason to explain the anomalous point that you have circled. Assume no error was made in the experimental value of the titer. Okay. If there is no experimental value of the titer has no error, which means the point, the time determined at this point, it has to be here. So जो टाइम है वो एक्सपेक्टेड से कम आया है. ऑल राइट. सो टाइम अगर एक्सपेक्टेड से कम आया है, दैट मीन्स, लेट मी राइट इट डाउन, लेट मी राइट इट डाउन. At 10 minutes, it's anomalous point, and the reason for this anomalous point is that the actual time, my bad, look, this was the source of error, record the time in step 4. So we were recording the time in step 4, which means the sample removed, the actual time of the sample removed was higher than the recorded time. So, which is why it was the possible source of error. Okay, let me write it down. Hold on. Actual time of the sample removed in step 4 was higher than the recorded time. Okay, यही तो कह रहा हूं मैं आपसे कि ये जो रिकॉर्डेड टाइम है इससे ज्यादा होना चाहिए था, यहां होना चाहिए था ये. ठीक है. Okay. Determine the gradient. My goodness. Determine the gradient of your line of best fit in figure 2.1. State the coordinates of both points you use in your calculation. These must be selected from your line of best fit. Give the gradient to three significant figures. Three significant figures. And we need to go for the gradient. So gradient could be from any point. So let me take 25. And the value 1.23, 1.23, 1.23. So 1.23, 0. That's the first point. And the second point was uh, um, can we take this value? It's 5. And then 1.467. These are the two values. So 5, 1.467, and then 25, 1.230. Let me calculate the gradient. Gradient was delta x over delta y. So it's going to be 1.467 minus 1.230 divided by 25 minus 5. Hold on. Let me check. Oh, my bad. It has to be, hold on. Gradient has to be delta y upon delta x. Delta y. So it's 25 minus 5 divided by 1.467 minus 1.230. I hope it makes sense to you. So it's basically 20 divided by, hold on, 1.467 minus 1.230, 0.237. XY. My bad. I'm getting saturated. My bad, my bad. Let me think again. Oh, that's so easy. The value of y is this, and the value of x is this, right? So it's 1 point. I was right before. 1.230 divided by 25 minus 5. Is that the case? Yes. Is that the case? So it's going to be 0.237 divided by 20. It's going to be 0.01185. And we need to put negative sign here because it's a decreasing gradient. So it's minus 0.01185. Okay. The equation of the straight line plotted in figure 2.1 is shown. Use the gradient determinant C4 to calculate a value of velocity constant or rate constant in second. So the equation is log V infinity minus Vt slash CMQ bracket close equals to uh, k upon 2.303 into 1 over t plus constant. Okay. So technically this entire thing is y-axis. Okay. This entire thing is basically the gradient, and it's represented by m. This entire thing is basically x-axis, and this is basically c. So it's basically y equals to mx plus c. That's the linear law. And gradient is what? Gradient is technically k over 2.303. We need to find the value of k. So k equals to, gradient was 0.01185 minus into 2.303. So the value of gradient is, value of rate constant is into 2.303 is going to be 0.02729, and it has to be minute inverse. I need the rate constant value in seconds, so I need to divide by 1000. Oh, sorry, divide by 60. 0.02729 divided by 60, it's going to be 4.54. An examiner is looking, so it has to be in the fourth significant figure, which means this answer needs to be in four sig fig. Okay. 4.54 8 into 10 to the power 4.55 into 10 to the power minus 4. My goodness. I hope it makes sense to you. वैल्यूज आगे पीछे हो सकती हैं बिकॉज मैंने ग्राफ अपने हिसाब से बिल्कुल ठीक बनाया है, तो आप देख लीजिएगा उसको अपने एंड से, ठीक है? On the basis of that value, you can get the answer. Use your graph in figure 2.1 to state whether you consider the results to be reliable. Give a reason for your answer. Okay. So my answer is that most of the points lie on the line of best fit. एक minute. At 15, 1.347. Yeah, that's a very close value. Let me set this value. Let me set this. It has to be more close to this point. So guys, you have to be very, very careful, okay? 1.347. This is 34, 345, 347. It has to be somewhere here. Okay. So most of the points lie on the line of best fit. Also, it's a straight line sketch, and that represents the first order reaction given in the rate equation. So I think but it's a decreasing gradient. So if concentration decreases, rate of reaction also decreases. So that's a straight line graph. I think it's reliable. Let me check one more time. 1, 2, 3, 4. We have 6 points. Out of 6, we have 4 on the point, on the line of best fit, 2 out of. So I think I'm writing. It's reliable because most of the points lie on the line of best fit. Also, straight line shows its first order. Okay. But in the marking scheme, I think examiner has it not reliable. And the reason for this, most of the points do not lie on the line of best fit. Okay. But मेरा जो मेरा आया मैंने उससे उसके हिसाब से लिखा है, ठीक है. सो आई डोंट नो एग्जामिनर्स को नॉट रिलायबल क्यों कह रहे हैं, बिकॉज स्ट्रेट लाइन ग्राफ है, और जब स्ट्रेट लाइन ग्राफ होता है तो रेट कांस्टेंट और रेट जो है वो दोनों इंक्रीज हो रहे होते हैं. दैट इंडिकेट्स द फर्स्ट ऑर्डर रिएक्शन विच सेटिस्फाइज द रेट इक्वेशन आल्सो. सो आई डोंट नो व्हाई एंड व्हाट्स द लॉजिक बिहाइंड दिस. ठीक है. बट मैंने दो, मेरे पास जो आंसर मुझे लग रहा है मैंने वो लिख के दिया. मार्किंग स्कीम भी बता दी आपको क्या है. आई थिंक you need to choose the best one. K increases the temperature. Okay. The second experiment is carried out at higher temperature. So if temperature is higher, higher value of K, more steeper, is sketched. Then experiment 1 starts from same y-intercept, only gradient increases. So when temperature increases, gradient increases. So what we can do here is same intercept 25. This is okay. So more steeper gradient, more negative gradient. I hope it makes sense to you. That's the end of this question also. Thank you very much, guys. And if you find any mistake in calculation, just ignore that, all right? Because, you know, it's very tough for me to read the graph because of the overlapping of the small boxes. Thank you very much. Take care. Bye bye.